this is the last section, G and H. I did find my mistake on that last problem, number 15. For whatever reason, turned this 19 into a 9. So I reworked the problem. I didn't record myself reworking it, but I did finally get it to work out. Still ugly and evil, but you end up with this for your answer. So I did work it out, and it's going to be in the video notes if you want to see the worked out solution to 15. So last section, linear optimization. And remember, what we do here is we need to graph all of these systems of equations. And once we graph them, we find the corners and we plug the corner coordinates into the objective function, which in this case is 3x plus 2y. So let's give this one a shot. Starting with x and y are both greater than or equal to 0, and if that's true, that means I know I'm looking in the first quadrant. I do need to solve for my y's here, so for this equation, I'm going to subtract my 2x, and I'll get, subtract my x, that can be negative x plus 4. I will divide by 2, which gives me negative 1/2 x plus 2. And then this equation right here, I will subtract the x. That will give me negative y less than or equal to negative x plus 1. And then when I change the signs, multiply everything by negative 1, you get y greater than or equal. Remember to flip the sign. Get Mr. Sandlin to come dance for us. And there are the inequalities. So let's get my x and y axes on here. Y-axis, I'll put my x-axis right here. And then I need to graph these lines. Starting with x and y are both greater than 0. That means that I will be shading to the right of the y-axis. That's x is greater than or equal to 0. And I'll shade above the y-axis, or I'm sorry, the x-axis. And that's because my y-coordinates must be greater than or equal to 0. And then I have these two lines. I have negative 1/2 x plus 2. So I'm going to go up 2, and then go down 1 over 2, down 1 over 2, down 1 over 2, and I'll graph that line. And it's going to look something like this. And if y is less than that, that means I'm shading below. So we're going to shade down here. Whoops. We're going to shade down here. And then my last one is x minus 1. So if I graph the line x minus 1, that's a y-intercept of negative 1 and a slope of 1. So I'll go up 1 and over 1, up 1 and over 1. And that line looks like this. And let's see, it is y is greater than. If y is greater than, you shade above the line. So I'm going to shade this way. And we have this tiny itty-bitty region where all of the shading overlaps, and that is right here, real small region. And we need to find the corners of that region, so let's find the corners. My corners are, I have a corner at the origin, 0, 0. I have a corner at 1, 0. I have a corner at 2, 1. And then I have another corner up here at 0, 2. And then we plug each one of those corners into the function 3x plus 2y. That's my objective function. f of xy equals 3x plus 2y. And then I'll plug in 3 times 0 plus 2 times 0 is 0. 3 times 1 plus 2 times 0 is 3. 3 times 2 is 6, plus 2 times 1 is 8. And then 3 times 0 plus 2 times 2 is 4. And then I want the maximum and minimum. So my maximum occurs right here. And you know what? I'm okay if you just want to draw a box around it and say, hey, there's the max. My minimum occurs not right there, right here at 0, 0. That gave me my smallest value. So there's the minimum. Good, good? Good, good. So I have max at 2, 1 and a minimum at 0, 0. Let's try 17. Same thing. All the lines are in slope-intercept form. That's nice. Let's see. I have a y-intercept of 2, a y-intercept of negative 1, and a y-intercept of 4. So let's see. I'll put my y-axis. Geez, I I'm not limited to the first quadrant here. I never said that my y coordinates are positive, so I guess I'll put my y-axis in the middle. I think I'm going to need more room above. Oh, wait. Actually, I did say x is greater than 0. So if x's are positive, that means I'm going to be on the right side of the y-axis. What I don't know, though, is, geez, why am I having such a hard time? Is what my y's are going to be doing. So my y's, let's see, I'll put my y-axis right there. And then let's start graphing. This one, negative x plus 2, so I'll go up 2, a slope of negative 1. So let's graph that one. And remember, these graphs need to be as accurate as possible. I want that to be green. There we go. And then I have 2x minus 1. That's going to be a y-intercept of negative 1. Oh, I've got to shade. I've got to shade that first one. Y is greater than. That means I'm shading above the line. So I'm shading this way. Okay, 2x minus 1, that's a slope of 2 and a y-intercept of negative 1, so I'll graph that line. That's going to be like this. And y is greater than means I'm shading above again, so I'm going to be shading this way. And while I'm shading, I'm always keeping an eye on my overlapping region. Right now my overlapping region is this section right in here. Then I have negative 1/2 x plus 4. So let's go up to 4 and a slope of negative 1/2, so down 1 over 2. And that looks like this. Let's see, for this one, y is less than, so I'm going to shade down. And then my final one is my x's must be positive, which means I'm going to be on the right side of the y-axis. So I'm going to shade on the right side of the y-axis if my x's have to be positive. And my shaded region, the final shaded region, is this small region right here. And then we'll do the exact same thing we just did on the last problem. I'm going to list all my corners. My corners are, I have one at 4, 0. I have one at 0, 2. I have one at 1, 1. And I have another one at 2, 3. And then I will plug those into the objective function f of xy equals 5x plus 0.5 y. Ooh, we're going to have some weird decimals. Okay, so 5 times 4 is 20 plus 5.5 times 0, and that's 20. 5 times 0 is 0 plus, and then half of 2 is 1. Okay, so then I have 5 times 1 plus 0.5 times 1, which is 0.5. So that gives me 5.5. And then plug in 2. 5 times 2 is 10 plus 0.5 times 3 is 1.5. That gives me 11.5. And then my maximum occurs right here. And my minimum is 1. Good. All right, I think there's one more problem. Yep, write the system of equations that yields this graph. Let's start with what I consider the easiest one, this vertical line. That is a vertical line at 2, so that's x equals 2. It's the equation of the line, but I shaded on the right side, so that means x is going to be greater than or equal to 2. For this line right here, the y-intercept is negative 1, so I know it's going to be something times x minus 1 for the y-intercept, and then I'll just pick 2 points that the graph goes through. It looks like it goes through those 2 points, and that's a rise of 2 and a run of 1, so that's a slope of 2. And I'm shading above, the shaded region is above that line, so that's going to be y is greater than or equal to 2x minus 1. And then the last one, this line that's sloping down has a y-intercept of 2, so it's going to be something plus 2. And if I pick 2 points that the graph goes through, I have 1 point here, looks like it goes through that point. That's down 1 over 2, so that's a slope of negative 1/2. And I shaded below that graph, which means y is less than or equal to negative 1/2 x plus 2. So there are your system of equations for this problem. Find the slope, find the y-intercept, write it in slope-intercept form. And then if you're shaded above, y is greater than equal to, shaded below, y is less than equal to, and we'll go with that. So there it is. Those are all the answers to the review. Hope this helps you.